this node is to be the first node as well as the last node, because this is the first time we insert this node. Okay, so for the first node, what is our job? In the first node, our first job to set null value into the next part, because always we do the job of next part of the new node. So what will be the new node's next part? Because of this is the single node, so next part should be null, because this is the first node as well as the last node. So we prove that this is the last node by inserting null value into the next part. Okay, so now we set null value. Now if all of you know that this condition, when it is satisfied, that means font contain the value null. Okay, so font means right now null. So if we assign font into the temp next part, the new node's next part, so font means basically null, so we actually assign the null value into the next part of the temp. So now we assign the null value, that is from the front. Okay, so null is set into the next part. So right now this is the last node, represent the last node, because next part contain the null value. Now we have to make this node as a first node or the front node of the queue. So it is possible if the base address of temporary node or the new node is to be assigned into the front. So now it is possible if front equals to temp, because the new node is nothing but a temp, that base address of new node is held by temp. So temp contain the base address, temp contain the base address of new node, that is 2000, and temp own address, suppose 9000. So temp is assigned into front, means the value of temp 2000 is assigned into front. That time front will be point to this new node. So that means front equals to temp, and take return. So this is the procedure of, or this is the piece of code by which we insert the new node as a front node as well as the last node. Clear to all of you? Okay. Now suppose the node is already created, sorry, the list is already created, and again we want to insert. So now this time we don't know how many node is there, because we know only the font, and that is contain the base address of first node, and new node, that is hold by the base address of new node is hold by temp in different location. Suppose the second time when insert operation call, so that time again the memory block will be allocated by malloc function, and the base address of that block of memory is stored into the temp. This temp is different memory location, maybe this temp is come into this location, suppose. Okay, and new node, the new node is allocated, sorry, control X, control V, at 3000. So after allocation, the base address of new node is stored into temp. So temp contain the base address of new node, that is 3000, and this is the queue is already created. Okay, now we request to the user, that is enter the priority and the data. So according to the input we store. Now suppose the priority is 1 and the value is 3. Okay, so now where this node should be inserted? Okay, so this time we have to check. You can understand, according to this priority, this is higher than the first node. This node priority is higher than the first node. So that means right now, who is the first node? Okay. Before that, we have to insert this node. That means insert at beginning. Okay. So same code will be same. So but we have to check this node. So we have to check the temporary node's priority with the first node priority. This is the first. If you want to do the program or the algorithm easily, so you have to split the job into small part. Okay, small part, you have to split the job. So right now, first time we do the job for the fast node, and this time if the fast node next priority and we are compared the fast node priority and the temporary node priority. That is, if temporary node priority is less than fast node priority. You can see fast node is pointing by front. So fast node priority is less than temporary priority. So if value, we are comparing the value basically, whose value is less, its priority is high. So temp P is less than front P. That means priority of temporary node's priority is higher than the priority of front node. Clear to all of you? So that time we have to insert the new node or the temporary node at beginning position. So for the beginning position, if we want to insert this new node at beginning, so that time we know the new node next part should be done fast. So that time this new node will be the first node. Okay, so its next part contain the base address of currently first node. Who is the first node? That's base address. So that means new node, because of new node will be the first node, its next part should be contain the base address of the node who is right now first node, and that is contained by front. So we have to assign this value of front into the next part of new node. Clear to all of you? So that is why the code will be temp arrow next equal to front. You can see here temp arrow next equals to front. That is why this 2000 assigned here. So that means it will it will come and sit into this location where so this is the linking. You can see this is the linking. So now after that, this new node, when this new node will be the first node, when this new node will be the first node. So it is possible this new node will be the first node or the starting node or the front node if and only if front point this node or point front contain the base address of this new node that is held by temporary. So If we assign this value of temp into the front, that time front will point this node. So we have to write here front equals to temp. So if we write here front equals to temp, so this 3000 is assigned into front. So that means front is point in this node, and this will be break. So after that, the new node will be the list will be 1 and thereafter 2, sorry, 3 and thereafter 5, or we can say this will be control X. Look like this. Okay, so now after that, so this is purpose, this two node, this node is inserted when the list was empty, and this node is inserted when it the its priority is higher than first node priority. That is why we insert at beginning position. Okay, now we have to now we have to visit from throughout the list or traverse throughout the list and reach into the particular position according to new node's priority, and we have to insert that node within the list. Okay, so suppose the new node allocated at 4000 and temp is point at 4000, the priority is 2, suppose.